Good afternoon, everyone. It's a pleasure to be here. My name is Claudia Wijaya. I'm a representative of this paper evaluating deep learning for CT scan COVID-19 automatic detection. Next. We are living in a time where a global pandemic is greatly impacting our daily lives, and urgent solutions are vital to tackle the current situation. This research aims to provide a more efficient alternative by appraising the practicality of machine learning to automate the detection of the COVID-19 virus through CT scans. So let's discuss the backgrounds of this paper first. Firstly discovered in Wuhan, China, the COVID-19 is a highly infectious disease affecting over 220 countries worldwide. Contractions of the virus have been reported to cause problems like respiratory infection. Next. And frequently displayed symptoms include fever, coughing, sore throat, shortness of breath, headaches, nausea, and diarrhea. And they may often be accompanied by fatigue and anosmia. Next. So even with the safety precautions such as the following being implemented, the number of cases continues to surge. Next. And in this part, I'll be discussing the problems we want to tackle. So to detect COVID-19 in patients through CT scans, radiologists will look for ground glass opacity, known as GGO. So if the findings reveal patchy, bilateral, peripheral, and subpleural markings, a scoring is then given based on the severity for the doctor before deciding on further course of treatment. Next. The main concern of present solutions is that it is time consuming and prone to human errors as the process is manually conducted, and with limited personnel, automation is very essential to significantly improve efficiency, minimize inaccuracy, and prevent misdiagnosis. So to solve such issues, we propose training a few deep learning architectures to detect the presence of COVID-19 through CT scan and assess the performances of the two different models, which are LINET and VGG16. So we integrated a data set from Kaggle, which utilizes 7,000 samples, positive COVID samples, and 6,000 samples for non-COVID individuals. Okay, next. And shortly after this, we will display the results obtained from the two methods. So the first being convolution neural network, followed by transfer learning, and how gradient weighted class activation mapping, also known as GradCam, is applied to both architectures. So experiments were then conducted to compare training the model from scratch to using the transfer learning method. And these experiments were performed on a total of 14,486 CT scan dataset. Next. So let's move on to the demonstrations and the results section. I will play a video provided by one of the authors of this paper to showcase our CNN model.
So this is a demo for testing the COVID detection using CNN. So I'm using Google Colab. You wanna make sure your runtime is on GPU. And let's run the code. So in here, I want to put in my G drive, my drive for the data set, or you can get it on my GitHub also, but I'm just going to use my drive. And I'm extracting the zip file. After that's done, you have the data set on your collab. I'm just gonna make sure everything's here. So we have the training and also the validation. This is already a processed data. The raw data is available in Kaggle, and you can get the link again in my GitHub. And this is the CNN network. It consists of 3 convolutional layer, and I max pooled it 2 times. So the original size is 256, then it gets factorized to 128, and then it factorized again to 64. And this is going to take a while to train, since again we have 6,000 data, 6,000-ish. So yeah, let's just wait. Alright, so it's done training, and it looks like the best accuracy we got for training is 97% and accuracy 86%. Now let's go to the inference. Let's run the model using the best model we got, which is the last one. Yeah, it's the last one. Then transform. Now let's visualize our validation. As you can see here, it's a pretty good model. Only got two wrong classification, but the rest is pretty good. Right now, let's move on to the testing. So I'm just gonna go ahead and upload a test image. So I just created a new folder here, call it test, and I have this one image, which is this one, and this one is an image of a CT scan that is COVID. And this is just a test, and all of this is actually detected of COVID. This is all COVID CT scan. And by the way, I haven't used that data on the training and also validation. And this is a brand new data for testing. So I'm just gonna go ahead and run this. And I'm going to enter the path. Copy that Just paste it. And it is detected as COVID, which is correct. I'm actually gonna try uploading more image. Just try uploading two here. Let's upload 5, so we need 4 more. There you go. And I'm going to test it out again. Let's see, and it's all correct. As you can see, all images are detected COVID, positive for COVID. So that's it for the demo, guys. Thank you for watching. So this is a demo for test.
All right, so that is a video of our demonstration for our CNN model. We hope that was clear enough. So here are the results. So the graph on the screen are our current results for the CNN, and with a training and validation accuracy of around 86%. While the graph on the left shows our training and validation loss comparison. Next. And here are some samples of the CNN model tested on a new dataset. And as you can see, our model did a good job of classifying COVID and normal CT scan. And as mentioned before, we made use of GradCam in our code as well. And in the case that the input image is a chest CT scan of someone with COVID, the GradCam will then return a heat map of the same image in order to show the area of the lung with GGOs. And as you can see from the images on the screen, the areas with GGOs are marked with red on the GradCam result. And on the other hand, the surrounding area reduces in hue, which altogether shows how the code recognizes the COVID symptom. When compared to the CNN model, our transfer learning approach is done much faster. This is because we used a pre-trained model, which is VGG16, since it was created for large-scale image recognition. And the images on the screen are our results, with a training and validation accuracy of around 85%. And here is the result of the use of GradCam on the transfer learning model. Next. So the next step is to analyze the obtained results and examine the two methods. So to do that, we employed a few evaluation metrics. So this includes training time and flops values, which are laid out in the following table for either model. F1 value is responsible for measuring the balance between the model's precision and recall, thus producing a better picture of how well they do their job. On the other hand, the flops value is a measure of the computer's performance capabilities. So going back to our table, results show that the Lynette model requires more time to train than the PGG16 pre-trained model, pointing out a noticeable advantage of using a pre-trained model. The Lynette model, however, it yields a higher F1 measure, suggesting higher classifier precision. And in addition, the Lynette model also has a reduced flop score. Despite its higher accuracy, less computational power is needed to execute overall. So in this paper, we showed our investigation on several methods, which include training a model from scratch, which is the CNN model, and training a model using a transfer learning based method, as well as implementing a GradCam to detect the presence of COVID-19 infection using a chest CT image. The experimental results show advantages of the CNN model compared to the transfer learning model, despite having its advantages as well. And in the future, we plan to expand our work by implementing a similar approach to predict the COVID-19 severity level. So that brings us to the end of this presentation. I would like to thank the chair for the given opportunity, as well as the audience for listening. Have a nice day, everyone.
Right, thank you so much, Miss Claudia, for your presentation. Right, so seems like Mr. Armin already has a question here. So let's do the Q&A session right away. Mr. Armin, you can ask the question now.
Okay, thank you. It's very nice presentation and also very clear. Congratulations for nice work. My question would be, since the input are images, pictures, how is the images are being represented as data sets? Would that be one way, or are there many options of doing it? What is the considerations for creating data set out of images? Thank you.
Okay, thank you, sir, for the question. So for our case, we are making sure that the images are in .jpeg format, but we've taken a look at others' works as well. They use different sorts of format files for their images. So even one of a paper that we were looking at, they were using a 3D image of the CT scan instead of just having it as just a 2D picture of a slice of the CT scan. So it really depends on what we're considering, because at the moment, data sets such as like the 3D scan that I mentioned before, there weren't a lot of data yet for those for 3D in 3D. But when it comes to 2D CT scan images for COVID, there are actually already a lot that has already been published publicly. So we were very fortunate to find a public data set that has compiled 15,000 images of the CT scan images, and they were also, every single one of them were very clear and has already been and it's already pretty, there aren't any like problematic images that may affect the accuracy of the model.
So
I hope that answers the question.
Yes, it does. The images are coming from chess.
Yes.
That's correct. Yes. So
yes,
it's the image about the area about surrounding the lungs, right?
Yes.
I see. Maybe final questions. Why the training result cannot go to 100%?
I believe that if it goes, if it goes towards 100,000, I think that could possibly mean that there is an overfitting issue. So we did our best to find like the good balance to make sure that it's not overfitting or underfitting as well. Because the first time that we tried doing this paper, we were struggling with it being underfitting. We were lacking in data, but we managed to figure it out. So yeah, the highest that we could reach right now is that it's around 86% with the validation.
Okay, so that's the number when you test the results, or you test the training sets?
When we were testing the training set, yes.
I see. Okay. Okay, thank you. Congratulations. Nice work.
Thank you.
Thank you, Mr. Armin, for your question. We have more time for one more question. Is there anyone else that want to ask? Right, if there is no one else that want to ask, we will continue on to our next activity. Again, thank you so much, Miss Claudia,